Here we're going to look at how we can work out the volume of the reaction vessel. We've been given the initial moles of A and B and the moles of C at equilibrium and the value of Kc of 1.85. I'm going to do a Rice table and put the data in. So I've got 0.5 moles of A initially, reacting with 0.75 moles of B with no moles of C, and at equilibrium I've been told I've got 0.2 moles of C. The change in moles of C then is an increase of 0.2. The equation tells me for every mole of C which forms, a mole of A and B react. So the moles of A and B will both decrease by 0.2 to give me 0.3 moles of A, 0.55 moles of B at equilibrium. Now write an expression for Kc, concentration of my products, or the concentration of my reactants, and that's equal to, as it says in the question, 1.85. The Kc expression requires that we have concentrations, and of course we've worked out moles here. And concentration is of course moles divided by volume. So the concentration of C now is the moles, 0.2, divided by a volume which we want to work out, and I'm going to call that volume X. Divided by the concentration of A, which is the moles of A's 0.3, over again this volume of X times the concentration of B. The moles of B are 0.55. Again divided by this volume of X. And that's all equal to 1.85. Now this is just a maths problem where we need to solve this for X, and first thing we do is we cancel these two X's out, and that would give me the following. Now to simplify this, I'm going to bring this X up there. And we now should be able to simply solve this for X. We divide both sides by 0.2, multiply both sides by 0.3 and 0.55. And that then gives us X as being equal to and when we solve that for X, we get an answer of 1.53 decimeters cubed, and that is the volume that the reaction has taken place in.